Here we have a sad-looking Philco tombstone radio, a model 38-93 to be more precise. I picked this up at the flea market for a cheap price, and as you can see, the front is all torn up. These sets originally used a photo finish on the front. Well, obviously that's shot. So the only thing I know to do to fix this is rip all this mess off and apply some new veneer. And I think there's a company that makes repro photo finish decals for various Philco sets. I'm not sure if this model is included in their offerings, but well, one way to find out. And what's odd is, as chewed up as the front is, the rest of the cabinet is not in that bad a shape, really. Got some scratches there that can be dealt with pretty easy, but everything else is solid. In fact, the rest of this cabinet, I think all it'll need is a good cleanup and it'll be good to go. Here's the back of the set. As you can tell, someone has worked on this before me. We have a more modern power cord, and somebody's been messing with the speaker wires. You know, it really worries me when I see sloppy repair work like this. It makes me nervous as to what I'm going to find when I pull the chassis. So, with that said, I don't want to stay nervous for very long. So let's just go ahead and remove the chassis and see what we can find. And notice the large bolts that hold the chassis in requires this 10mm nut driver to remove them. And by the way, this was a lower end radio for 1938. I believe it cost $22.95 back then, but in those days, lower end was usually still decent quality. Okay, here's the underside of the chassis. It's obvious that someone has worked on this recently, judging by the newer capacitors in here. And I see some sloppiness here where they used electrical tape to insulate a wire lead here. And this is a more modern multi-section filter capacitor. They paid way more for that than they should have. They should have just used a couple of individual sections and been done with it. But yeah, this is probably going to be one of those deals where I have to go in behind somebody else and clean up their mess. Okay, before we proceed with the cleanup on aisle 3, we'll do a few basic checks to make sure all of the major organs are in proper order. And that first major organ that we'll test will be the power transformer. We want to test the high voltage winding, the filament winding for the rectifier tube, and the filament winding for the other tubes. Now the high voltage winding should be a center tap, should read about 600 to 700 volts across the winding, so 3 to 350 volts AC from each side of the tap to ground. Let's see what we have here. Okay, 318 volts, I can live with that. Let's move to the other side of the winding. 318 volts there, I can live with that. And checking across the filament winding, I'm getting 5.3 volts, I can live with that. And checking across the filament supply for the rest of the tubes, I'm getting 6.8 volts, and that's very much acceptable. So the power transformer is good. Now, before I insert the rectifier tube, I want to figure out this mess with the filter capacitors. We have these two that someone installed, and we have this capacitor that's 33 microfarad, 160 volt, 47 microfarad, 160 volt, and that voltage rating is much too low for a transformer operated set. This would be like what you would find in a standard 5-tube AC-DC set without a power transformer. According to the original Philco filter capacitor can, or I assume it's original, we have a dual 8 microfarad, 475 volt sections here. And it looks like this is 10 microfarad at 50 volts, so that's likely a bypass capacitor for the audio output tube, although it's not shown on the schematic. Although the schematic I'm using is for a 37 model, they didn't have a 38 model listed. And yes, my printer ink cartridge decided to run dry on me, but we got enough to go on anyway. Okay, correction, I just found the 10 microfarad capacitor. It's not a cathode bypass, it's actually a filter capacitor for the bias supply. You see this voltage divider resistor network here. That's where our bias voltage for the tubes is developed. And since this is negative voltage here on our bias supply, that means that our positive end of the capacitor will go to the chassis, and the negative end will come off of our bias supply source. That's a mistake a lot of people make. They get the capacitor wired backwards, and I won't be surprised if that's what I find here. Much to my surprise, everything looks to be wired correctly regarding the filter capacitors, and they have this particular one in the low voltage bias supply, so the 150 volts won't be an issue there, although I am going to take this out and wire something in that'll look a little neater. Okay, now I guess we can insert the rectifier tube, fire it up, and go from there. Okay, I'm checking the DC coming off of the rectifier tube. About 30 volts input. We're already up to like 125 and climbing, so looks like that portion's working. Gradually raising the AC input. Whoop, need to go up to the next highest range here. And our B plus is dropping, so that means the tubes are warming up and starting to conduct. I'm getting some static from the speaker. Won't it be something if after all this the radio actually plays? Okay, I'm at 120 volts line input. Okay, what just happened? We lost it.
Scarlet O'Hara.
Okay, we appear to have an intermittent connection either with the rectifier tube or the socket itself. I wiggled it and the voltage came back. And as you can hear, we're actually playing. Imagine that.
I didn't know until I was
volume seems to be a little bit weaker than it should be, and
20 years. How about that?
I'm detecting some distortion, but
learn something new every day?
At least we're playing, so that confirms that all the major organs are good. We just have to correct all this sloppiness here. Okay, this may be the cause of our intermittent power supply. Here's the filament lead to the rectifier tube. And notice we have some wiggleism here, which means it's not soldered good. So let's temporarily resolder that and see if that corrects our intermittent B plus voltage dropout. Okay, there we go, resoldered, and that should take care of the dropout problem. These particular socket terminals don't have through holes, so you just have to bend the wire over into a J-hook and then crimp it on there. But that should take care of the problem, and I went ahead and placed some heat shrink tubing over this filter capacitor lead. Looks a lot neater than electrical tape, don't you think? Okay, here's the coupling cap in the audio circuit. A 0.015 microfarad couples the plate of the driver tube to the control grid of the output tube. And the capacitors contained inside of this Bakelite block here. Most Philco radios of the 30s contain capacitor blocks that look like this. I believe this particular one only contains one capacitor, although some of them contain several capacitors and even some resistors. Now, they're not that hard to deal with. It's not like melting the tar out of an Atwater Kent power supply unit. These are much easier to deal with. You just have to unbolt them from the chassis and then use a source of heat to heat the tar, and then you can usually pull the whole plug, the whole component plug, if you will, out of the case, and then you can fit a modern component inside of the old case. Well, what some dodo did here is, instead of eliminating this capacitor from the circuit, they simply jumped a 0.22 microfarad, which is much too big anyway, across the old capacitor. Well, when you jump a good part across an old one, then you still have the old leaky capacitor in the circuit to cause problems. So that's why we need to eliminate this capacitor altogether, and then rebuild this Bakelite block capacitor with the correct value part, and then we should be in business. Okay, I've removed that big capacitor that someone had installed. I have not rebuilt the Bakelite block capacitor yet. Right now I'm checking the plate voltage on the driver tube. The voltage is not specified on the schematic. However, I'm reading about 19 volts. We just go ahead and round it up to 20 volts. But that's too low. I'm looking for about at least 50 or 60 volts here. And if we look at the circuit, the plate of the driver tube is fed through a 0.19 meg or 190 k ohm resistor. It goes down to the B plus supply. Actually, it's taken off of the input to the output transformer, the B plus input to the audio output transformer, as well as the screen grid of the output tube. So let's check that resistor and see what it reads. And I said we're supposed to be reading 190K. Well, we're reading 960K, so that's a great deal more than what it's supposed to be. So let's trace out that resistor and replace it. Well, actually someone has already taken the liberty of replacing that resistor. Unfortunately, they replaced it with the wrong value. Here we have two 470K resistors wired in series, so that's almost a meg ohm there, where 190K ohm should have been. They probably misread the schematic or whatever. Well, who knows what they did. I don't try to figure out what incompetent repair persons do to these things or what their motives are. I just straighten out the mess. But anyway, let's get this out and put a more proper resistor in here. Okay, in preparation to replace this resistor, disconnected one end of this block capacitor here. Thought we'd go ahead and test it. Not getting any eye deflection when I rotate the dial. Not a good sign. And even on the lowest leakage voltage rating, the thing's leaking like crazy. We're not flashing, we're glowing. So yeah, that capacitor is very leaky. So we might as well just go ahead and pull it out and rebuild it while we're here. Here's the underside of the capacitor. You see what has to be removed. You just heat this up and the whole thing should just slide out, and then you can install a modern component and you'll be good to go. Okay, here are the guts out of the block capacitor. The easiest way to remove them is with a heat gun, but I'll admit I don't have one of those at the moment, but that's going to change real soon. So I just use an old soldering iron to heat up the insides, and then I plucked them out with an old screwdriver, and here's the result. You see the modern capacitor down in there, and we just simply run the leads up through the holes here, wrap them around the tie points, and solder them in place. And there's no need to refill this cavity with anything. It'll do just fine. Now, when rebuilding one of these tar blocks, as I call them, obviously you need to know what's inside of this, and there are two ways to determine that information. Number one is the schematic diagram for the radio, which requires some tracing out of the circuit to determine what's where. And number two is there's a book that I think Antique Electronics Supply sells, and I think I might actually have a copy somewhere that gives the internal values and the schematic diagram of all of these Philco Bakelite block condensers. You notice a number stamped on the case here. You just look that number up in the book, and then it will show you exactly what's inside of this Bakelite block and how it's wired, and that's the easiest way to do it. Okay, we have our rebuilt Bakelite block condenser back in place. We replaced the almost 1 megohm resistors that someone had in there with a 220 k ohm resistor. The original resistor was 190 k. I didn't have that. It was either 150 k or a 220 k, so I just decided to go with a 220 k. And that's a lot better.
Here on WBR and bringing you the very art.
Don't get too excited. That's just the intro to a talk show.
Somebody was out there saying 2/3 of the votes didn't have it. 2/3 of voters didn't have it. I heard of Wolsey in charge.
Okay, before we had 20 volts on the plate of the driver tube.
And of course,
after we corrected the boo-boos, we now have 77 volts. That's much more acceptable.
They were just, oh my God, mana from heaven.
As you can hear, the radio is happier now. Now we need to go through here and correct this other mess that was made. Okay, I found another goof up. The plate bypass capacitor for the output tube appears to be, well, the value on the schematic is kind of smudgy, but .00 something. I ended up going with a .0068. What they had in there was a .022. It's really not that critical because all this is a tone compensation capacitor. The higher value capacitor you have going from plate to ground, the less high frequency will be allowed to pass through to the speaker. But, you know, keeping with the original design, I wanted to go closer to what was in there, so that's why I replaced this cap with a .0068. Okay, next we need to work on this Bakelite block condenser that actually contains two condensers. Condenser number one is this .01 microfarad that goes from one side of the AC line to chassis. Condenser number two is this .1 microfarad bypass capacitor that goes from the 6K7 to ground, and also from the 6A8 to ground. So we're going to have to remove and clean it up real good and make this look a little bit neater. Looks like they've already replaced the .1 microfarad cap in the grid circuit, but I don't think they replaced the line bypass capacitor. Okay, before I gut this condenser block, let's check its internal parts. First, we're checking the AC line bypass capacitor section, and I'm getting basically not enough to say I'm getting anything from the tuning eye. Now let's test it for leakage. And you can see the light is flashing like crazy even on the lowest voltage setting. So yeah, that section is leaky. Now we're checking the grid bypass capacitor section. Getting a little more tuning eye activity here, but not the nice, sharp, well-defined opening that I would hope for. And it's leaky like crazy, as you can see. Normally, had this been an unmolested radio, I could probably leave this Bakelite block condenser still wired in the set and just move it out of the way to gut it and restuff it. but since I'm having to clean up somebody else's mess anyway, it was just easier to remove this and clean it up. And it looks like right here where they broke off part of the terminal where this was originally soldered. Okay, here's our restuffed Bakelite block condenser. This black one is a special line bypass safety capacitor, 0.015, and this is our 0.1 microfarad bypass capacitor in the grid circuit. And since they broke this terminal off, I had to fabricate a terminal out of a piece of wire hooked on here. That'll make it easier to reattach what's supposed to be attached here. Okay, I've tried to clean up this sloppiness as best I could. Fixed the power cord. Originally, they didn't even bother to have a rubber grommet here, which you really need to keep the possible sharp edges from the chassis from compromising the insulation on the power cord, so we corrected that. And I got rid of the electrical tape that was on the power cord for whatever reason, and resoldered everything that was done previously to a higher standard. Okay, let's fire this thing up and see what happens.
Miami.
Okay, we're
Miami then can show, hey,
we're playing, obviously.
And producing results that produce the win on Tuesday. Isn't that the I was striking a rock and those.
So we still have a little bit to go before it's done. Okay, I found out the problem. It's causing our little bit of squealing. We have a faulty ground connection where I reinstalled this capacitor block. Now 1260 out of Baton Rouge, playing R&B. Now here it is with the ground connection established. This is what happens when I remove the ground. You can definitely tell the difference there. And the ground connection that's broken is this AC line bypass capacitor, as well as this 0.1 microfarad grid bypass capacitor. And this is the one that I believe is causing our squealing by not being grounded properly. So let me investigate that a little bit. Okay, the problem is where this bolt attaches here is supposed to make contact with this, establishing a connection to the chassis. That wasn't making a very good connection, so I just simply soldered a short piece of wire here and ran it under this bolt and tightened it down real well, and now we have a good ground connection. Okay, I guess the next step,
the most important thing is setting a good,
is to neaten up the speaker cable a little bit. I'm a little bit afraid to pull this cover off of the speaker down here. Afraid of what I'm going to find. But there's no time like the present, so let's pull it off and see what we have to deal with. Wow, they actually soldered the wires in place. I can't believe it. Okay, that takes care of neatening up the speaker cable. I simply ran the cable through the hole in the cover where it's supposed to be, and I eliminated those connectors that someone had installed, and I just spliced the cable together and used heat shrink tubing to insulate it. and then I bound it all together with black electrical tape. So that looks a lot better than the way they had it done.
You look at the World Series.
Okay, I think all that's left to do is clean up the chassis a little bit and touch up the RF and IF alignment, and this chassis should be good to go. Okay, I did a little minor cleanup on the chassis. I didn't go crazy with it. I just got the superficial dust and crud off. I now have the signal generator connected, and as soon as everything warms up and stabilizes, I'll proceed with the alignment. Now, most super heterodyne radios have an IF frequency of 455 kilocycles. Well, this one has an IF frequency of 470 kilocycles, so when you're aligning a radio, you want to make sure you know what your IF frequency is, and that's usually given on the schematic. Now, after about 1940 or so, they pretty much standardized on 455 kilocycles, but the older stuff could be all over the map. So, you want to make sure what your right frequency is before you proceed. We'll align these trimmers in the proper order for maximum output. It's obvious that one was off. It's obvious that one's way off. We'll need to turn our signal generator output down. There we go. Want to keep the generator output as low as possible to get a decent reading. If you use too much output from the signal generator, it will cause the AVC circuit in the radio to kick in, and that will give you false readings. Okay, now doing the first IF transformer. Obvious that one was a little bit off. Oh, that one's way off. Now, what we'll want to do is reduce the output of the signal generator even more and repeat the procedure until no further improvement can be made. Okay, I went back through and peaked these trimmers. They're about as close as they can get to perfection. Now we'll need to adjust these trimmers on the tuning condenser. This is our oscillator trimmer, which determines the dial position, our dial calibration. This is our RF trimmer. Okay, I'm feeding a 1500 kilocycle signal into the antenna input, and there's very little effect when adjusting this trimmer, so I just set it back to the approximate position that it was originally in.
And Quicken Loans is
here. Well, that woke it up a good bit. Only thing I need to do is touch up the oscillator adjustment, and I can do that once the set's in the cabinet and the pointer and the dial and all that is placed back where it should be.
Easy. And for
I believe we're tuned to WSM right now.
Highest in the nation in customer satisfaction for primary mortgage origination. Call 800-QUICKEN. West of the Middle East, the foreign governments repeatedly send cyber. This Croc show. I tweeted how good if we're
grow my business so much, I had to bring on new staff.
Hey, if Web.com would say he's not going to do it because in order to pardon someone, you have to acknowledge they're a criminal, right? So he's not going to take his friends and say they're...
I don't know where that interference is coming from.
Side with the junkyard, where are you going?
Right, so take your break.
It's probably WDIA.
Picked up his fourth personal foul. our bands tonight, as
they're very busy and perfect.
popular people.
Hold it. Zero post-game report. Our report. Anything can happen. It's high school football. Train formation again behind Murphy.
And that's it. About the only thing I need to do is patch up that speaker, and I think I should be done with it. Now, the only other thing that checks a little weak or a little off is this 6Q7 tube test a little weak, so it might need to be replaced in the near future, but as you can hear, it's working right now. Okay, I'll leave you with the sounds of WSM. There you go. The 38 Philco back operational again. Should be good to go for another many decades. Thanks for watching, and more to come later.